Badri, and this is STEM Session 1 for first grade. The topic of the presentation is getting to the other side. And perhaps you can start by asking how many kids in the class know hello from the other side, or maybe not. So, the first part we're going to do is review what STEM is. It stands for, as you know, Science, Technology, Engineering, and Math. It's a program created by the Office of the President to prepare more kids in STEM careers because data shows that kids are going to be far more successful 15, 20 years from now when they enter the job market when they either have exposure to or an education in STEM subjects. And even if they do not end up being engineers, every one of us has exposure to products that are a result of engineering, and that is why it is important. Well, then the question is, what is technology? And maybe you want to ask the class, hey, can you give me examples or can you define technology? And very commonly, the kids in class are going to give you examples of technology. They're going to say a cell phone is technology, or a computer is technology. And the crux of what we are trying to deliver here is that technology fundamentally is something that solves a problem. You have something to do, and you're going to create something that solves that problem. That is technology. It can be an object, it can be a system or a process. A paper cup is technology. Why? The problem you're looking to solve is how can I hold my coffee and not have it spill all over the place, and not have to lick it off the table. And a cup solves that problem. It absolutely is technology. It's a human-made technology. It's made of certain materials. People thought about the design of it. So these are the questions that you would want the kids to think about and say, do you understand what technology is now? And maybe you can then say, hey, how about you come up with what technology is? And at this point, parents are encouraged to maybe take a glue stick from home and say, is glue stick technology? Yes. Well, what does a glue stick do? Well, it is used to apply glue. Well, what did people think about when they designed the glue stick? Well, I don't want to stick my finger into a pot of glue. I'd like for the glue to be contained in a little stick. I'd like to be able to turn the bottom of the glue stick to have the glue stick out of the top. I'd like a cap so it doesn't dry out, stuff like that. And if you don't have a glue stick, take a stapler. It doesn't really matter. Just use a simple aid to convey the point that technology is something that solves a problem. Then we're going to say, gee, is technology only things that move? Is it only computers and smartphones? Does it require electricity? And maybe kids can come up with examples of technology. Now, fruit and a vegetable is not technology. Then the question is, who creates technology? And engineers create technology. How do they create technology? They use STEM processes and they use the underlying subjects in order to address the problem, and the result of it is technology. What kind of engineers are there? There are many kinds of engineers, and anyone can be an engineer. Can only grown-ups be an engineer? Not really. Here are examples of kids that said, I have a problem. My problem is that my ears are getting cold. Chester Greenwood said that, and his parents probably encouraged him to create an earmuff. And, George Nissen, I suppose, was a very jumpy old kid, and he created the trampoline with the help of other people. So the point is to encourage kids to think about problems, attempt to solve problems, and become engineers. Now, who are civil engineers? These are people that design structures. An example of a structure could be a building, a road, a bridge, a tunnel, and so on. Then the question is how engineers create technology, and now we come to the story. There is a kid called Javier, and he's trying to cross a stream. Well, he needs a way to get to the other side of the stream. And the story itself happens in Texas. And the kids would have read the story already. You are free to read it as well. The online Dropbox folder has the story or a condensed version of it that you can read. A kid falls in, they try to rescue it, and Javier is not happy about it. He tries to solve the problem. He starts designing a bridge at home. He recruits his friends. They start looking at various kinds of bridges, and they go back and they build that bridge. They camp out and they celebrate the birthday, and boy, they solved a problem. And that really is kind of the crux of the story that Javier needed to solve. And he solves that by asking questions around a process called the engineering design process. And the process generally involves asking questions, imagining solutions, planning what they want to do first, creating prototypes, and then improving the prototype. And so then the question is there only one kind of bridge? There are many kinds of bridges. There are beam bridges, arch bridges, cable bridges, suspension bridges. And at the end of the day, if you think about what happens to a structure, if you think about our own school building, the weight of the ceiling is pushing down. It's trying to twist the cables, and therefore we need beams in order to make it strong. And thus, if you create a bridge by putting a piece of paper between two blocks, a car really is not going to be able to go through it. Similarly, if you create a bridge like what you're seeing on the right hand side and there is a lot of wind, the wind is going to blow it away. So you really need to think about how you are going to design a bridge that is not going to fall down. And there is no check sheet, worksheet, so kindly let them know we're not doing worksheets this year. But we'd like to encourage them to start looking at bridges, and let them know next week they will each be given an engineering challenge to design a bridge. And so you will come back in a week or so, and they're going to be building bridges. Thank you, junior engineers, and that is the end of this story.